Hey, today we're going to be talking about similar shapes. Similar means shapes that are the exact same shape but different sizes. We're going to get into this pretty quickly today. Let's go on ahead and get started. As always, if we move too fast, remember you can always pause and go back to make sure you write down everything you need to write down. We're being told that triangle ABC is similar to triangle DEF. And that means a couple of things. It means that all of that squiggle, first of all, means is similar to. It also means that all the angles are congruent because angles don't change size. It still has to add up to 180. So we know that angle A is going to be congruent. See, back to the congruent symbol for angles to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. So that's good. That's good. But unfortunately, the sides aren't equal. We can see that on the picture. We happen to know that these match up with each other. And so the way we're going to write this, first of all, the proportion of AB to DE should equal the proportion of BC to EF, should equal the proportion of AC to DF. And that means that AB is 10, which matches DE, which is 15, should equal, when we reduce it, BC, which is 8, over EF, which is 12, should equal AC, which is 12, over DF, which is 18. So this reduces by 5 to 2/3, reduces by 4 to 2/3, reduces by 6 to 2/3. Getting all wrapped up in my head. And they are all the same ratio, so we know that they're similar. Now, we're being asked, is ABCD similar to JKLM? So we're going to check. These match up. These match up. These match up. These match up. And we're going to reduce them all to make sure they're the same. So 8 over 14 equals 8 over 14 equals 8 over 14 equals 12 over 21. All of these divide by 2, and we get 4 over 7. So 4 over 7 equals 4 over 7 equals 4 over 7. And then this divides by 3. And we get 4 over 7. So yes, ABCD is similar to JKLM because we checked. All of these were the same. They had to be the same or they wouldn't be similar. And the question also says, if they are similar, write their similarity ratio in the most simplified form, which is 4 to 7. That's all you do for a problem like that. Writing out the ratio in its most simplified form, that's all it takes. Now the next problem says, are they similar? Check the existing ratios. If they are, solve for x. We know 12 is going to match 24, and 5 is going to match 10. And 13 will eventually match x, but we can't reduce that because we don't know the values. So 12 over 24 equals 5 over 10. These both divide by 12. These both divide by 5. We get 1/2 equals 1/2. So yes, they are similar. And we happen to know that we can set that equal to the ratio now. 1 was the smaller triangle, 2 was the larger triangle. So 13 is from the smaller triangle, x is from the larger triangle. We're going to cross multiply and solve. 2 times 13 is 26. 1 times x is x. There's nothing else to solve. That's a fairly easy problem, but just to get the point home. So perimeters also have the same similarity ratio. These are perimeters. That's what's in this fraction. And it's just saying the ratio of the perimeters is the same as the ratio of the sides. So the ratio of the perimeter, which is adding all the sides, is the same as the ratio of the sides themselves. So LM is equal to the ratio of LM to QR, equal to the ratio of MN to RS, and equal to the ratio of NK over SP. And you can pause here, but we're going to roll forward because we have this problem where they're telling us we've got a new basketball court that is 20 feet wide and 25 feet long. And we know that regulation, this problem is silly because we know that courts have a certain length they're supposed to be. But here we are, and the old one is 16 feet wide. So first we're going to find the scale factor, and the only things that we have that match up are the 20 and the 16. So we've got 20 to 16, and we have to reduce. And the only number that, I know I'm moving fast, sorry, but the only number that they reduce by is 4. So it will be a 5 to 4, because 20 divided by 4 is 5, 16 divided by 4 is 4, so a 5 to 4 ratio. That's part A. Part B is find the new perimeter. So the good news is courts are rectangles, so if that's 25, that's 25. If that's 20, the bottom's 20. And we add these all together, and we find out that the perimeter of the new court is 90. We're going to use this to find the perimeter of the old court. So they have a 5 to 4 ratio, where 5 comes from the new court, 90 comes from the new court, so it matches with 5. The unknown perimeter comes from the old court, which is x. We'll cross multiply. 5x equals 4 times 90. 4 times 90 is 360. Divide by 5, and x equals 72 feet. I know that was fast, but we still have another example problem to go, similar to that. Similar might be the wrong word since it's about similarity. But this problem, the only thing we have that matches is 40 and 72. So 40 over 72 equals, and then we need the perimeter, and P equals 72 plus 63 plus 81, which is 216. That was from the same triangle as 72, so that goes down there. The unknown perimeter goes on top. And we are going to cross multiply and solve. 72x equals, I want to say, 8,640. Yeah, I'm going to punch that into my calculator real fast, which might give you guys a second to breathe. I'm sorry we've moved so fast. That is divisible by 72. X equals 120. So the perimeter of the XYW triangle is 120. It should be a good start for your homework assignment, lesson 6.3 homework. I will see you in the next video. And again, you can always go back and rewatch, or you can message me if you have questions about a specific problem on the homework, and I can try to help you with that problem. I look forward to the next lesson. Thanks.